Good morning, everyone. I was talking with Miss Gomez last night, and she mentioned that there were a few problems on the homework in 4.1 and 4.2 that were causing some issues. So I thought I would do a couple examples that are similar to those. So hopefully that will help you out on your homework and alleviate some of the frustration and confusion. All right, so the first one we're going to look at is a coin is tossed 8 times. What is the chance of getting all heads? All right, so the first thing we want to do is we want to find the size of our sample space. All right, so there is a formula to do this. The formula to do this, so formula to find the size of the sample space is, I'm going to put up an equation here. You take the, let me add something here. The computer's kind of slow, and now it's froze. So we're going to wait for just a second. There we go. Okay. You take the number of possibilities and you raise it to the power of the number of trials. All right? So here, since we're talking about a coin, we know the number of possibilities is going to be 2 because you can get heads or tails. Okay? So the number of possibilities is 2 since a coin has one side that is heads and one side that is tails. Okay? We know that the number of trials is 8 because it says our coin is tossed 8 times. So that means that the total number of outcomes in our sample space is equation sign. It's going to be 2 to the 8th power. And you just do this in your calculator, and that comes out to be 256. So what this 256 means is whenever you toss a coin 8 times, and let's say, for example, the first time you toss this coin 8 times, you get heads, heads, tails, tails, heads, heads, tails, tails. All right? That is considered one outcome. All right? So there are 256 of those outcomes. There are 256 ways to arrange head and tails. But the thing is we only want to know the chance of getting one of those outcomes. We want to find the probability that when we toss our coin 8 times, we get the set heads, 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 and heads. Is that 8? 1, 2, yeah, looks like 8. Okay. So that means we are only looking for one outcome out of that 256. So that means the probability of getting all heads is equal to I'm going to put a fraction here, is equal to 1 over 256. I'll make that bigger here in case you guys need to see it better. All right, so then in Hawks, you can either enter it as 1 over 256, or you could enter it as the decimal. All right, so the key for this is anytime it tells you to take one object and to repeat a trial over and over, in order to find the total number of possibilities in your sample space, you take the number of outcomes in your sample space. You take the number of possibilities from your object. So for a coin, it's 2. For a 6-sided die, it would be 6, because there are 6 numbers, so there's 6 possibilities when you roll it. And then you take that and you raise it to the power of the number of trials. So I'm going to do a second example to hopefully cement that in. So let's say a 6-sided die is rolled 4 times. What is the chance of rolling a 2 every time? All right. So first, we find our sample, the size. First, we find the size of our sample space. Remember, sample space is the set of all outcomes that are possible. Okay. So in order to do that, we first consider the number of possibilities on the object we're looking at. So the 6-sided die has 6 numbers on it. So there are 6 possibilities. There we go. And now we need to consider the number of trials. It says that it is rolled 4 times, so there are 4 trials. Oh, goodness gracious. So this means that this means that the sample space has six to the 4th number of outcomes. All right. So one moment, I'm going to put that on my calculator here and figure out what that is. 6 to the 4th is equal to 1,296. Okay, so 1,296 possible outcomes in our sample space. All right, so now that we have the total size of our sample space, we want to think about how many of those outcomes we're actually wanting to achieve. Well, in this situation, the only outcome we want is that we roll a 2 each time. So that means the desired outcome is 2, and then another 2, a third 2, and a fourth 2. All right? So that is only one outcome from our entire sample space. So that means our probability of rolling a 2 each time is equal to 1 over 1,296. All right, okay, so let's move on to another type of problem. What is the probability of rolling a sum of 7 on a standard pair of dice? So first, we want to find our sample space, the size of our sample space. In class, whenever we were finding sample spaces, our sample spaces were small enough where we could just list them out. But on a few of the questions on your homework, they're too big to list out. So that's why I'm making this video and showing you the formula for how to find the size of your sample space should the numbers be too big to write them out individually. All right, so we want to find the size of our sample space. So here, we have to look at it a little bit different. So we have 2 dice, or 2 die, here we go, something like that, you know what I mean? And each of those have 6 options on them, okay? So we could think of this 2 ways. We can consider holding both dice in our hand and throwing them. So that would kind of look like one trial of 2 dice, or 2 die. Or we could think of it as taking 1 die, throwing it, getting the number, picking that die back up, throwing it again and getting a second number. So what that would look like would be having one die with 2 trials. And in order to use our formula that we talked about in the first 2 examples, that's the mentality we want to keep. One die with 2 trials, because that's going to help us calculate the size of our sample space. So we know the number of possibilities on a die is 6. The number of trials is 2. So the size of our sample space is wrong symbol. One moment. Is 6 to the second power, which we know is 36. We need to decide out of those 36 outcomes, how many of them result in rolling a sum of 7. So at this point, I'm just going to start listing them. So we know that one option, the first roll we could have a 5, and the second roll we could have a 2. That's going to result in 7. It also could be the other way around. The first die could be a 2, the second could be a 5. We also have 3 plus 4 is 7, and 4 plus 3 is 7. We have 6 plus 1 is 7, and 1 plus 6 is 7. So that gives me 6 different outcomes that result in a sum of 7. So in order to find the probability of rolling a sum of 7, we want to have 6 over 36, which gives us 1/6. Oh, and let me scroll down so you can see that. All right, so that means the probability of, if we toss 2 die and we want a sum of 7, the probability of rolling a 7 is 1/6. All right, so let's look at one more, and this one is one where you have, this is from 4.2. So the ones we just did were from 4.1. This one's from 4.2, and it's the one with the large and small marbles. Ms. Gomez mentioned that there was a lot of confusion about this one as well, so I want to go over this one. So we have a box contains 20 large marbles and 12 small marbles. Each marble is either green or white, so we only have 2 colors. 5 of the large marbles are green, and 6 of the small marbles are white. If you randomly select from the box, select a marble from the box, what is the probability it will be green or large? Or I'm going to switch that around. Large or green. All right, so the first thing I want to do is I want to remind you of the equation. So let E be the event of drawing a large marble, and F be the event of drawing a green marble. So that means the probability of E or F is equal to the probability of E. What is that symbol? I have no idea. Plus the probability of F minus the probability of E and F. All right, so let's find the probability of E first. So E was drawing a large marble. So probability of E. What in the world? All right, so the probability of E, we know that we need to take the number of large marbles, which was 20, and divide it by the number of marbles overall, which is 20 plus 12. which gives us 20 over 32. And I'm not going to worry about simplifying them at this point. I'll do that at the very end. All right, so now we need to find the probability of F, which is the probability of drawing a green marble. Okay. So we can see that 5 of the large marbles are green. But in order to know the total number of green marbles, we need to know how many of the small marbles are also green. But we're not told that. We're just told that 6 of the small marbles are white. But we know that whenever you're talking about the small, sorry, I just got a text from my mom and it distracted me. Even I have a mom that texts me. Okay, let me refocus here. So, we know the number of small marbles that are also green, but we're told that 6 of the small marbles are white. But if it's not a white marble, then it has to be a green marble. And if we have 12 small marbles and 6 of them are white, then that means the other 6 must be green. So I'm going to type that out here. So we have 12 total marbles. Okay, 6 are white, because that's what they told us. So we need to find out how many are green. We can see that 6 are green. So since 5 large marbles are green and 6 small marbles are green, then 11 marbles overall are green. Right? So now that means the probability, I'm going to use the abbreviation, the probability of F is equal to the number of marbles that are green, which is 11, all over the total number of marbles, which we already said was 32. Okay, so that's our probability of drawing a green marble. Now we need to find the probability of a marble being both large and green. But this is the nice part. They told us in the problem. They said 5 of the large marbles are green. So we have 5 marbles that are green and large. So the probability of E and F is equal to 5 over 32. 5 large marbles that are also green over the total number of marbles, which is 32. All right, so now we can plug them in to our equation up here, this probability of E or F. So probability of E or F is equal to, insert an equation here. Okay, so the probability of E or F is equal to the probability of E, which we said right here was 20 over 32. So 20 over 32 plus the probability of F. We said the probability of F was 11 over 32 minus the probability of E and F, which we said was 5 over 32, which gives us 20 plus 11 is 31. 31 minus 5 is 26. 26 over 32, which reduces to 13 over, let's see, 16. Yeah, I believe so. 13 over 16. I just did that in my head, so don't quote me on it. You can put it in your calculator, get a decimal. All right, so that means that our final probability is 13 over 16. All right, well, I hope this has helped you out. If you have any questions, feel free to email me, text me, or talk to me in class on Tuesday. I hope everybody has a great weekend.